I'm Lindsay Lewis, editor of Building Enclosure. Thanks for listening along with us today. On April 9th at 2 p.m. Eastern Time, we have a free webinar, Strategies for High Performance Below Grade Waterproofing. Benjamin Meyer, Building Enclosure Business Director with Siplast, and Andrea Wagner Watts, Building Science Education Manager for GAF, Siplast Building and Roofing Science team. They are both here today to talk about their upcoming presentation. Andy and Ben, thanks for sitting with me.
Thanks for having us.
So to kick off, high performance enclosures are often discussed in terms of above grade systems. So below grade waterproofing frequently, I feel like, is underestimated. What are the consequences of treating it as kind of an afterthought?
So it really comes down to out of sight, out of mind, right? Just like you said, we all focus on the above grade stuff, and it's really easy to forget of the parts of the building that are hidden. But at the end of the day, because it's hidden, it's really hard to fix. So if we have a leak in our roof, it means that we can get up there, we can fix it pretty easily. We can suss it out, figure out where the leak is and repair it. Once we're behind concrete, under the dirt, it becomes much harder to find those issues in a timely manner. So repair bills can be massive. We have to tear up sidewalks. We have to get between buildings that potentially are really close together. High repair bills, mold issues if we don't find it soon enough. It really can start to, roll downhill and really build in the expense if we don't do it right.
All right, I'm going to ask a fun building science question now because I know it's your favorite. Can you break down the fundamental physical forces like hydrostatic pressure, capillary action, and water table fluctuations, and explain how those specifically threaten structural durability?
Sure. I mean, those are the most exciting questions, right? The building science one. But I think to Andy's point, that's why it's so important, because all these things are happening, you can't see it. But like hydrostatic pressure, so there's water in the ground. We hear, groundwater, water tables, things like that. So that's literally water that's in the soil mix, and it's pushing against the surface of the walls or underneath from below into the floor. So like the structure has to be designed to withhold that water pressure, but also the waterproofing membrane itself needs to be able to resist that increased level of force that you wouldn't necessarily see on a roof, because it wouldn't have that ability to kind of accumulate. And so capillary pressures, this is a little bit different. Like if it's exposed to water, the materials themselves can act like a wick or a sponge. So concrete is kind of an open porous structure. It's very hard, it's very strong, but it has pores inside of it. So it has the ability to draw water into it. So that's capillary action, where it's being pulled in. And that can also happen at interfaces of materials and joints if they're not properly detailed. And then to kind of make it even more challenging is, you dig a hole and you're looking for water. What you see today might not be there all the time. So you can have fluctuations by season. You could have, extreme variations where it can be very dry, but you have a rainy month. And that could be the month you're designing for. You can't assume it's going to be dry 90% of the time. So we'll do a 90% good job. You gotta have to design for that 10% all the time.
Now, at what point in the design process should below-grade water and gas mitigation strategies be integrated? And what red flags should team identify during early site evaluation?
Yeah, so a lot of this comes from early project assessment, whether it's environmental assessments or geotechnical, where they're looking at the soil composition. A lot of the clues are going to show up there, like the height of the water table, are there any wetlands, things like that may seem unrelated to the building. But that's kind of the first trigger to say, hey, we have to design for this. Even though we're going to put a building in this natural space, it's going to actually need to resist all those forces.
And when comparing positive side and blind side waterproofing systems, what are the critical decision-making factors for complex urban projects?
The first consideration is what is possible. In a perfect world, we would always do positive side waterproofing. We'd be able to pour the concrete foundation and then be able to apply the waterproofing directly to that concrete. We can quality control it. We can make sure it's there, it's adhering, it's doing what it needs to do before we backfill against it. However, we get into the urban core, we get into inner cities. We're in almost zero lot line construction in a lot of places, so we don't have room to dig a deeper pit than the foundation itself. In that case, we have to apply the waterproofing to the shoring that's holding back that earth, pour the concrete against it, and that's the blind side or pre-applied waterproofing. Now, That works and it can be done very successfully, but you have to do it right the first time because you can't see it. You can't check it after the concrete is poured.
So, speaking on that, when selecting a waterproofing membrane, what are the most important technical performance characteristics that designers should be evaluating?
Yeah, it's a tough one because I think there's so many rules of thumb in the building enclosure space. We say, well, I need this thickness of this membrane. That may be the least important thing. You need to make sure that it works for this application and these details. If you go down a certain technology path, whether it's liquids or membranes or SBS sheet goods, then you need to make sure that everything works together. Because really, what you're looking for is a complete system. There's no one technology, or if you're a few mils off in the thickness, that's not going to be winning and losing. It's going to be all the details and the coordination. So if you especially, we talked about it's hard to get to. Well, also the building's going to move over time. So do those materials have the ability to adjust or to move with the cracks, construction joints, and design? That's part of it. And then also, we talk about if the site is contaminated, or if there's a known radon gas that you're trying to manage around the building, having the longevity to be able to not just perform, in the lab, but also in application after many years and still do the job it's supposed to do, because you can't go back and, swap it out later on.
Now, beyond foundation walls and underslab applications, where across the building envelope is waterproofing most commonly overlooked?
Oh, it's almost always overlooked. There's so many prettier places to spend your money in a building. But I think the bigger challenge is waterproofing, especially on zero lot line construction, is complicated by the process of construction. So you think about like crane pads. You dig a hole, and the first thing you're going to do is have to waterproof the crane pad, because that's going to be there. It becomes a permanent part of that foundation, even though it's intended really, it exists for temporary crane construction. And so it adds complexity where in an ideal world you wouldn't have it. And then that kind of, you can work from there. You have elevator pits and things like that have again, more complexity than just, flat sides and flat bottom that you have to kind of deal with and navigate various systems and various sequencing. That crane pad may start and they may not finish the waterproofing for 3 or 4 months later.
Now, it seems like most waterproofing failures often occur at transitions or interfaces. Now, what specification strategies could help eliminate ambiguity between trades and kind of ensure coordinated execution?
Step 1, get rid of the phrase by others everywhere in your set of drawings or your specifications, because you hit the nail on the head. These are the weak points. These are the points where trades come together. This is the point where in a foundation space, for example, we have the earthwork guy coming, followed by the contractor doing the waterproofing, and then you're pouring the concrete after that. And then we have to tie all of that waterproofing into the wall that's being built above it. And we can't just say, okay, here's our foundation plans and here's our wall plans. You actually have to make sure that the details are in your drawings, that we get past install per manufacturer's instructions and actually show these interface details and the spots where these different materials meet. And then we take that to a pre-construction meeting or a pre-installation meeting, and we have all these contractors in one room and say, okay, where's the point you're stopping? When's the next person coming in? How long is that going to be afterwards? Is everyone clear on the roles and responsibilities before we get on the job site?
Now, if you guys could give architects one key piece of advice for developing performance-based waterproofing specifications that reduce these failures, what would it be?
You have to prioritize the coordination between trades, and you have to work with partners that are going to provide the support you need. Working with manufacturers who can provide you that technical support early in the design phase to make sure you're not going to come across these issues in the field. If you can find that right technical partner early on, they see these systems day in and day out. Their job is to know these materials and these systems better than you are. They're going to be able to help you spot the scope gaps, spot these common places for failure, and flag them before construction even starts.
Now, lastly, I want to ask, what else will you guys be going over during the presentation?
Well, like I said, the fun parts are the building science parts. So we're definitely going to kind of, we'll go over the basics, but also kind of a little bit more of the why, like why is that important? So we'll kind of talk from design perspective around, material selection, things like that, but also from within the materials, what to look for, what are attributes that are going to be really important, whether it's adhesion to green concrete, because especially in foundation construction, that's a common occurrence. So how do you deal with that, and what technologies are best suited? So we really dig into kind of what makes things sticky. But it's also important if you're doing post-applied or pre-applied, that you need a good bond between the concrete surface and the membrane itself. So kind of digging into what are these key performance attributes and how to design for them. Because there's many things on the data sheet, but one that may, if you talk about adhesion to concrete, well, it doesn't necessarily mean adhesion to wet concrete. And you should expect that the concrete in your foundation is going to be wet. So how do you make sure you stick to it and stay stuck?
Well, thank you both again for your time today.
Awesome.
Thank you.
To register for this free webinar, head to continueducation.bmpmedia.com. Until next time, visit us on buildingenclosureonline.com for your technical and educational resources.